All right. Yeah. A lot of you've asked for this one. I'm going to prepare. Um, what all is on the first gen RX7? That's a huge list. So like 10 years of kind of R&D uh, refinement type stuff. So, geez, where do we even start? Um, by the build design, like when I started off, um, I said I want to build a solid axle rear end design car with McPherson strut that handles as best as a McPherson strut solid axle can. And so I grabbed inspiration from, I believe they're called like Trans Am cars, is the Trans Am Racing Series, was where it derived from, with the help of Paul Yaw of Inject Dynamics. Um, Yaw powered suspension, same guy. So he gave me a set of parameters. He said, check out trying to get your arm, your link design, to hit this height and this angle and this thing. That's it. He said, the rest of it, go ham. So I created a system to where the forelinks are incredibly long, and therefore, as they stroke through the suspension height, you would be gaining very little pinion angle change. We're talking like 0.2 degree pinion angle change per inch of stroke. If you've got a 6-inch stroke suspension like I do, very minimal. So your U joints at the drive shaft are going to be, simply put, never under load. They're always going to be at the correct angle, which means you could run more power through that same axle setup. Okay, so rear end first. I did a triangulated forelink. So the upper links are parallel. The bottom links are triangulated. You guys have seen it a few times. The rear anti-roll bar is being done right now by Race Factory. Really exciting. And once I built that around what I intended my power goals to be, which at the time I think it was about, I think I said like 375 or 500 horsepower. So I was not really aiming for the fences. I designed a setup that would be good for 800 plus wheel horsepower on the rear end. And I made a simple mistake on the housing, twice, mind you, that Toyota 8-inch housing from a 4Runner would have been perfect for the design. I messed up, and here's where it's going to bite me in the ass, is I don't have individual wheel speed on the rear axle right now. If I had picked the later generation, it would have been a little bit wider, which means the offset of the wheels would have been changed. But it would have given me my 4-wheel speed, because I would have the 2 front from the FC hubs and the 2 rear from that 4Runner solid axle. So that was my first like real mistake on the build. I said, okay, well, it's already truss, which means it's got reinforcement on the top and back to handle a lot more, power going through it, right? It comes from the off-roading industry. And anyone who has these axles, they're like, yeah, we can run 37s all day long on a semi-floating solid axle. So 37-inch tall tires off-roading with maybe, let's say, 150 to 250 horsepower. And I've got a little tiny car that weighs half that on a 25-inch tall tire. We should be good about 800 horsepower. And I'm grabbing this stuff because when I worked with Lucra, the Dana 44 heavy duty from the C4 Corvette, that handled everything. That was a 700 horsepower rear end, easy. Like not even trying to break it. You could run that thing as hard as you wanted to. So rear end, first mistake, where that went out. And guys, mind you, this is going to be a little bit of a long video, so hang in there with me. And I go through literally every single part and design for this car. It's been requested a lot. So bear with me, hopefully break it up. This is a long one. Rear end design, done. It's getting a OSGkin 1.5 final drive ratio, or I'm sorry, 1.5 way LSD. It has a 456 final drive ratio, and the axles are a upgraded 300M, some chromoly upgrade that we redesigned to do a 5 by 114.3 lug pattern, hand done, came out beautiful. Rear end, done. Geometry, beautiful. The next thing I designed with FFR fabrication was the V-mount in the front, which I'm sure you guys have seen it. It's incredibly overbuilt. Probably 3 times heavier than it needs to be, and I might redo it out of titanium. And I'll actually ask Evan over at Race Factor if he wants to redo that. So that guy has the Griffin 3-inch radiator, which is a 3-inch core, mind you. It's freaking huge. I think it's a 24 by 15 and a half. So 24 by 15 and a half. It's got 2 FC oil coolers stacked. And then on the tops, I have my intercooler, which is a Bell intercooler. That is a custom, I think it's like a 28 by 12 and a half by 4 and a half. That thing was actually a take back. I sent them back my original design where we made intakes and stuff, and they used that original design to make a larger intercooler for me. So I think it was Mike over at Bell Intercooler, and there was also Guy, if I remember correctly. It's been at least 7 years. So amazing people to work with. The intercooler came out so good, and it fills out every part of the front of the car. We did a little minor trim here and there, and it really, really offset, like, this is a car with purpose. So we have about a 2,000 horsepower intercooler, air to air, and it's got big, I'll actually grab them. It's got big Spall fans on it. I picked these up in January 19th this year. Actually, Rob Dom just made a video of it. These things are beast. Okay, this is a 10-inch Spall brushless fan, and the whole car is brushless now. So that is definitely the way to go for efficiency and for, overall the way that you want a car to work. You want it to cool down quickly, and you want it to stay within a small region of temperature. So there you go. You got V-mount. You've got all your components there. The bottom fan is a Spall 16 brushless, pulls down. You got 2 of those 10-inch I just showed you guys that pull up out of the hood. It's got a track spec custom gurney flap hood vent. Then we're going to be ducting it out to, I've got some like diamond plate aluminum that we're cutting, welding. It's going to look sick. And if you don't like this, you don't have class. It's that good. So that's kind of the V-mount region. And then the next thing FFR did would be the turbo kit. So the turbo kit for this car is a Schedule 10 321 stainless steel. It's a 2-inch, which makes it a 2.375 OD, 2.185, I think, ID. And the idea was this thing is going to be a bad bitch. Through a lot of testing, we've seen that the reduced diameter design works better. Okay, I went all out. I went all the same size. If you go to a runner design that goes from a 1/2-inch plate to, I think it's like Schedule 175, and then it comes up to Schedule 2, that will actually make more power throughout almost the entire RPM band for boost setups under 25 pounds. I said, fuck that, I'm going for the moon. So Tony ended up doing the Schedule 10 2-inch the whole way through. And I said, I want to try to get 24 to 28 inches total runner length. So if you look from the port of the engine, mine goes over, down, around, sweeps over, and then comes back this way. So I made it as long as I could in that region. And that goes to a T4 flange, and it sits turbo up pretty high. So the turbo is very close to the hood line. And that was our defining factor, is getting it to where I can land the turbo where it needs to go. At that time, it was at EFR 9174. I've upgraded turbos way too many times. Don't ask me why. I'm an idiot. I already understand that. So that's where it landed. Real happy with that. And from there, now what I have is a G42 1200 compact, which I think has the better compressor overall layout, and I think the turbine wheel should actually be a good balance for the setup. So that then drops down a full 4-inch exhaust with a Stainless Brothers resonator right next to the T56 Magnum, which I'll get back into. The Borla kind of like oval mid-pipe muffler. Then it has this crazy oval transition where everything is hand cut on compound angles to get over axle and drop into the rear muffler section, which is a Stainless Brothers 17-inch overall length. Huge oval muffler. So I'm really trying to get the Gran Touring suite refined note. The one downside of steel is it's heavy, right? So if I redid this whole thing in titanium, it would have cost me 12 grand on just an exhaust. But, here I am. I can't afford that. There's no way. But I'm very happy with the way that it landed. The layout looks incredible, and every part of the transition from turbo to wastegates that are synced back together on a large, so they go 1.5-inch outlet to a 2 1/4 Y pipe. Then that merges back into the down pipe. And I told Phil, I said, Phil, we can't have this merge right after, because what's going to do is it actually creates a reversion effect of the turbo. I said, we have to hit at least 18 inches from the turbine wheel to the re-entry point. It has to be symmetric entry angle. Sure as shit, he nailed it. So I think we got like 24 inches behind the V-band flange, down pipe into the re-entry angle. So super happy with that. And that's the exhaust system. I guess the next thing is the engine. You guys want to hear that one? So with all of the drama of the previous engine, I'm still keeping it. It's going to be backup block because, like this other 13B here, that's going to go to a stock build for someone. I have no need for this. But my engine builder, Legend Motorsport, John Swide, the dude is brilliant. Like, he knows exactly what he's doing. I think that in the realm of engine stackers or porters or whatever you guys want to call it, like, the dude understands everything when it comes to what it takes to survive an engine. I've seen some other tuners on that setup of his. Similar car. It was FC. You guys have probably seen the red FC on the page. And they couldn't blow it up. And I couldn't blow it up. So it's a very, very good engine builder. Okay. Uh, Very happy with him. So what John and I figured out is I told my whole plan with the upper intake manifold, the staged air inlet, the drive-by-wire stuff. I pretty much tried to educate him on the technical side of what I've been trying to accomplish for about 10 years. And he said, hold on, I have an idea. And together we kind of formed this, what I think is a really cool balance idea for an engine. And I was already semi PP on the intake manifold. I said, we're going to stay that. I know we're going to lose a little bit of bottom end, lose a little bit of torque on mid range, but here's where I think we're going to gain. So, so that new motor. Thank you, Chip, by the way. The machining came out beautiful. Um, I had us sleeve the intake manifold to where instead of being, I think it was like inch and an eighth, I want to say, maybe inch and a quarter, we dropped it down about, I think it was like an eighth of an inch, maybe a little bit more. So in other words, we're making our semi PP smaller. What happens when you make things smaller? You usually gain velocity. So as with all the steps in airflow of an engine, you want to have largest, like your bellow or your velocity stack. You want to have it largest, and then as it comes into the engine, you want to be reduce, 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 reduce. And then on the exhaust side, you want it to be whatever it's the smallest at that exit, and then it expands outward. Otherwise, you're getting problems with back pressure, essentially. So John and I did that for the semi PP. We have a few other things I will not talk about, but there are very unique approaches to the inside of that motor. Something I've never seen, I've never heard about, I've never seen documented anywhere. If this ends up working as we expect it to, I'm going to probably do something like SAE article on it. That's really cool. So we're doing a street port primary, Bridgeport secondary, and the upper intake manifold has a flapper to essentially turn off the semi PP and the secondary runners. So that way we can try to get an idle that's like 1200 RPM, 1000 RPM, real steady, real smooth. And then when we need to, we get hood rad mode. The second I'm over whatever load we decide needs to be at, we open up the intake manifold to the rest of the motor, much like the Honda did for the IAB system. So there's that. That part's going to be done. I think John's balance for that, how he's figured it out, is downright brilliant, and I'm going to leave him to his methods because he clearly knows what he's doing. Now I've just said, here is money, and here is, whatever componentry to make things better and stronger than what you're already used to, which survived. So we both think this motor setup is going to be good for like 1,000 horsepower. The turbo is not, but yeah. So there you go, engine setup. The intake manifold kind of went through. The car's got all alpha locks all the way through it. So I've got a 4-inch at the throttle body, and I've got 3 inches at the intake manifold. I'm sorry, at the intercooler. And the serviceability is going to be stupidly good for that part of it. At the front of the motor, I just figured out the CWA 400 water pump mounting location. It's going to be in front of the V-mount, and I'm going to try to do almost like an exhaust hanger reinforcement bracket. So it's going to be a stand and then a reinforcement, then it comes up like a skid plate to the front of the V-mount, and then we'll duct the V-mount to it. So, or rather duct away from it so it doesn't catch any air. Water pump's figured out. I just order up the last of silicone to make that the lines much easier. Then I've got a heater cord line coming off that. That'll be easy. The ignition is a CDI. So fuel tech, because it has all CAN bus control and CAN bus diagnostics. So for me, I want to have as much integration for diagnostics as possible because I tune cars, right? Like so if I can get sensor data and as much information fed to me as possible, it's a win. As far as I know, FuelTech is the only company that has a CAN bus network for their ignition. If something is backfeeding something weird, or we've got a dead coil, or somehow we have like a weird amperage draw, it's all going to create a flag inside the ECU master. Be like, yo, coil 3 is doing this, enable engine protection mode blank, and protect my setup when I'm running really hard. I'm trying to still build this car for luxury grand touring. Silver State Classic, there's like similar one out in Texas, but the whole idea of that is you're wide open throttle for sometimes an hour at a time, hours at a time. And you need reliability. You need things to be working on the background to where, you don't want to hear something and go wrong. You want to be, the system realizes something is going wrong way before you do and does its effects to keep the car alive or keep you racing, whichever you choose. You can sacrifice the engine and finish the race, or you can say, hey, here's this engine fault code, drop this sucker down, limit that car, because you're wide open throttle 150 plus miles an hour for hours at a time. So that's where I think that ignition coil setup, wow, got shit in my hair from pulling the car. That's from for CDI system to have a proper CAN bus and tell me what's going on is definitely a huge value added to the car. For the brakes, I've got the new chase bays, which, why do they have 3 labels on chase bays? Well, we get it. It's Willwood. And you guys did this stuff in China, but you don't need to have 3 labels of your product on the product. It's just really gaudy. I wish I could just paint it right over it, and I might. So, chase bays brake, dual master cylinder with a 6.1 pedal ratio. The oil coolers are put in, I guess it'd be parallel? No. It'd be in series. Whatever. The idea is that it's adding it to where they're both as hot to cold, and they're not going to each other. They're separate. I always get those mixed up. I shouldn't be getting that mixed up. So there you go. There's oil coolers. You got brakes, CDI. The interior is a total clusterfuck. That's like 10 minutes of me talking about that just by itself. The steering rack is really interesting. So at FFR, this was the 3rd thing we did, or it might have actually been the 2nd before the V-mount, is we took the FB steering rack, because it has like the turn signal canceling part. Like, if you want to keep all your interior pieces, you need to keep that upper region of the steering rack. And we adapted it to the FB steering rack. The FC steering rack region I got from Peter Jeune. Thank you, Peter. That was freaking amazing. Brought down from Michael Vodak. This is, dude, it's got to be like 8 years now. And they brought it down, and it was a automatic FC steering rack. And then I had the steering subframe and rack. I'm sorry, steering column. I keep saying rack. Steering column from the FC. And then I joined it from this rack that I got from Frizz Lucky 7. That was definitely 9 years ago. To mate the FB and the FC steering column. And so Tony had to cut and keep the little D-ring portion of it and keep the collapsible portion, because in the case of an accident, you don't want to have that, column going through your chest and impaling you. So we kept the FB portion to where now I turn my wheel and it goes cancel, cancel, cancel for turn signals. That little tiny feature created a lot more work. So Tony made a system where it mounted to the firewall, 4 bolts through it, and it's reinforced there. It mounts at the top FB plate, 2 bolts here, so it's actually stronger than it used to be. And then that shaft goes down, hits the standard FC 3-port power steering rack. The power steering I'm keeping. I still need to figure out the cooler for that. It's going to be a pain in the ass. Trying to hang it between a few different things on like frame rail. I'm running out of room, and I've been out of room. So that's the next thing. Yeah, the steering rack system of having an FC front subframe on an FB is really cool. The one downside is if you're using the guide online, Alex, you're amazing. Love you, buddy. If you're using that guide, your caster will be very, very high. Because if you're centering it off the original bolt holes, which I think are the front bolt holes, that makes the entire subframe shift forward for where that car was designed. So if you ever look at my car, the wheel center line is nowhere near the fender wall center line. So I haven't measured it yet, but I'm assuming I'm probably close to 9 or 10 degrees caster. Pretty wild. Definitely pretty wild. So we'll see how that creates a jacking effect, and if it makes the car lose grip, because when you're creating that much variance of caster effect, you'll be very stable at high speed. That's a given. But it also creates an effect to where as you turn the wheel, it's actually jacking the wheel as you turn it. So it's jacking the suspension as you turn the wheel. We'll see how bad that affects the overall handling of the car. But for a McPherson strut car, that's usually the only thing to gain camber, because again, you're actually gaining height from the, I don't want to say binding, but from the arm itself doing this. It's a little interesting effect. So on the front suspension, since I'm on that subject, it's got a ball joint adapter to correct roll center height. And since we're using FC front coilovers, that's actually built into like a lower Heim joint. And then it's got a little spacer to it with a taper. And it's got it's just a real unique thing. But it adds about, I want to say 1 5/8 to the roll center height, which means that if you had a bump steer kit for your, let's see if I have one, for your outer tie rod. So your outer tie rod adjustment needs to be way more, since you're now raising the whole knuckle that much. So, of course, what did I do? I made a steering rack adjustment. My buddy Robert machined out steering rack spacers for me. Really fun little project. I think we raised the car about 3/8 of an inch at the steering rack. So that would create the issue, the bump steer could go away. So now I'm getting that set up, and then I've got a bump steer gauge actually behind me right here to finalize where that needs to go with the small micro spacers at the outer tie rod. So the geometry is pretty much a FC with a ton of caster with roll center adjustment built in to my custom knuckle setup. From there, I've got Performance MRP Brake, who they designed a custom setup for me to run the ABS hubs. So now I've got ABS speed sensor on each one. Drop those out to a Deutsch DT 2-pin, whatever it was. So that's pretty cool. Let's see, brakes, front suspension. I've already gone over rear suspension. That was a doozy. I guess the rear brakes are a Turbo 2, vented. Those are incredibly rare, apparently, so I'm going to have a hard time getting parts for that eventually. But as it is, parts are all brand new. It's a Hawk HP Plus pad on all four corners. I really like that pad for dual purpose. I think it's, besides the dust, which is a little bit high but not crazy, it's a very consistent pad. And being that I live 10 minutes from a mountain range and 10 minutes from another mountain range and 20 minutes from a third mountain range, it's very important to have good brakes. So I'm all about, if I have a little bit more bite and a little bit more, whatever wheel dust to clean up, it's worth it. I could definitely transition to wheels and tires next. But I think for suspension, that is it. It's going to eventually be a set of MCS three-way with a remote reservoir. I need to figure out a way to mount those things because those are going to be another thing that's going to be in the way. I've got Mavin Performance bracket for the CDI that I can think of in the other corner. Again, that's where I would put the MCS. It's not going to fit. So wheel and tire package. This is a set of Wed Sport TC105X. It's a 17 by 8 front, 17 by 9 rear, and offsets I won't release. It's just, one, I forget them. I know exactly what they are. No, I don't forget them. But the offsets were very specific to this car, that rear axle, that front geometry. If I were to tell you, you would never fit it for your system. It's not worth telling you. Tires up front are 235 4017 and rear is a 255 4017. And I tried doing that for a multitude of reasons because, one, having the same height sidewall, even though it's not a height, it's a ratio, is actually going to make handling a little bit more consistent. Two, trying to keep a minimal offset between the front and rear is really nice. So a square setup would be like 235 at all four corners. I know that couldn't handle the power. It's a rarity to even see a first gen with 235 front tires, and I can go just about, I think it's full lock to lock when the car is at its proper ride height, to where I'm using everything. I know when we were moving the car, when we were moving the car at Race Factory, I actually did rub somewhere, so I need to see where that was. And I'm going to add little bump stop to the knuckle, little bump stops to the knuckle. So 235s in the front are wildly large tires for first gen Rx7. The car weighs 2350, 2400 pounds, and that's just a lot of tire for that. So the 255s out back, you guys can see it's big booty Judy. It's as big as I can get in there. I have a set of 275s that I was trying to fit. So, quick tip, if you ever go to a tire shop and you see their throwaways or recycling, and you just ask them, you say, hey, look, you're paying to get rid of this piece of rubber. Could I just grab this for you? And so I picked up a 255 4017 and a 275, I think it was like 3517. It was just kind of a weird oddball size. And it was actually 275 4017, excuse me. And it just couldn't get it to fit. I could roll the fenders all day long. I can do what I can, but it's just out of room. Unless you mini tub the rear end of that car, there's no way. So 255s, when the solid axle articulates like this, it does actually have a region of the tire to where it's doing this. So this gets closer to our vertical point. So you can't really do as much tire as an independent rear suspension. You have to think about the articulation of the suspension itself, because now you're on a beam. So that's where I landed for tires and wheels. It's it's still not going to be enough. So with the Mtron ECU, which that's where I was transitioning next, with the Mtron ECU, I've got all sorts of traction control based on torque. So one thing is I'll have individual front wheel speed and combined rear speed through this axle design. And I'll have something to where I can have a slip ratio dictate the amount of torque to be pulling out. And in traction control, you want to think about what is the fastest reacting, most aggressive, and then what is the most gentle way of doing something as well. So when you're at the very, very fine limits, do you want to hold it there, or do you want to shut something down immediately to where you don't spin out? So you kind of do a combination of things in certain situations. And with having an accelerometer both on the ECU Master PMUs and having it on the ECU itself, you kind of get an idea of the front to rear yaw without actually using the yaw sensor, which I also have, but not using it. So with the Mtron's traction control, I'm going to be doing stuff that's wheel slip and really just kind of general stuff with that. It's drive-by-wire, so I can actually reduce the amount of opening of the drive-by-wire for the situation. It's a rotary, so you want to only do ignition-based retarding or cutting. You really don't want to be doing fuel cuts for that engine because it can misfire and have a hot spot. And there you go. Welcome to banana apex seals. So I have drive-by-wire and ignition cuts or retarding. So it's kind of three. I'm trying to think of what I can't tell you guys. That's what I'm. Oh, traction control. Yeah. So there's a lot of small controls throughout the whole car. The ECU's power is damn near limitless because anything you want to program, you can do it. Same goes for the PMU stuff. They're very, very open-ended. And when it comes to, I don't know, all the controls you can imagine, it's as simple as you want to design something, you think it up, and it goes that way. So I'm just going to probably end it right about here. We're almost at 40 minutes, and I realize I've just been rambling for the last 12, at least. Yeah, there's a lot going on with that car. Cooling is your friend. I didn't even go to the fuel system. The fuel system is freaking crazy. And I will cover that. So, on the return line, I've got a fuel cooler. And the fuel cooler for the return line is a CSF 8119, I believe it is. So it's a Dash 8. And the thing is beast. It can handle a bunch of stuff being hit against it because it's bar and plate. And yeah, fuel system's 2 Fuel Lab 48403s and dash 10 lineup with a A2047, I think it was, for regulator. And injectors are 1700X for primary and 2600X for the 4 secondaries. I think I'm going to leave it at that. I'll show you guys the next stuff. Take care.